Okay, cool. So we can go ahead with the first problem. So I think the problem was quite clear. So let's just repeat that with the help of the test case itself. So the very first input would be the number of test cases you would want to execute. Here is it's 3. The next value would be the value n, meaning the n cross n matrix. So n is 4 here, meaning for this particular test case, we'll have 4 cross 4 elements in the matrix. Then you will have your matrix. In this case, it is, let's say, 1 2 3 4 2 1 4 3 3 4 1 2 4 3 2 1. Similarly, for the next test set of test cases, you will have a value n, and there will be a matrix. Now, what you have to do is calculate for that particular matrix, calculate the diagonal sum, that is the top left to the right bottom corner diagonal, sum of the elements, and also return how many number of rows have repetitive numbers and how many columns have the repetitive numbers. So in this case, the very first matrix is quite unique. That is, no row has a value which repeats in the row, as well as the column values are very unique. But if you look at this particular matrix, the below one, it has 2 right there in the first row itself, right? So there is 2 2 2 2. So if you see that, in fact, every row and every column has repetitive values. Hence the output is the diagonal sum, which is 9 in this case, because 2 plus 3 plus 2 plus 2, the diagonal has a value 9, and all the rows and all the columns have repetitive values. So you return 4 space 4. So I hope the problem is clear to everyone. So anybody wants to pitch in for a better solution here, then maybe we can discuss what I did. So the floor is now open to you guys. Any good solution that you guys want to discuss?
I think the most optimal one was the one with where we use the set. I didn't find
Mm-hmm.
any solution other than that.
Mm-hmm. Okay. Yeah, the set sounds good. Anybody else having thoughts here? I think the core of the problem is how to recognize a row having a repetitive, values.
Yeah.
So if you can do that in a better optimal way, that sort of, that sort of solves your problem in a better way.
Mm.
Set is one approach that we have. Actually, interestingly, when I thought of this, I did a very stupid thing, and I'm not sure how to, if you can take a learning out of that. Uh,
Mm-hmm.
what I did was, let's say you have an n cross n matrix, so 4, right? I just wanted to ensure that the sum of the row is actually equal to the number of unique elements you would expect. So in any row, I would check if the sum is equal to n into n plus 1 by 2. Okay, because if there are 4 unique elements, the elements have to be 1 2 3 4, even if they are in jumbled order, that doesn't matter. The sum will be that only. But shockingly, that failed one of the test cases. And then I realized that approach is not right. Sometimes the sum might be what you expect it to be, but yet there could be repetitive elements. So then I had to go back to the set approach only. So that
Yeah,
didn't
that was my
work.
first
Yeah.
approach too.
Yeah, yeah. Because that sounds, big of one. You don't have to do anything.
Exactly.
You don't need extra space or anything. Okay. So if nobody else has another approach other than set, then maybe we can quickly look at the solution that I had. Okay. So this is the main code that this is Python, by the way. So I'm taking the test cases, and then for every test cases, I'm taking the input, that is n value, and I have broken down the problem into 3 parts basically. One is to find the diagonal sum, another is to find faulty rows and faulty columns. So I have created a different function just for the clarity purpose, that it's able to read well, right? Let's go back to my function. So finding the diagonal sum is quite easy. I am creating, um, I wish I could maximize this. Let me show you in the editor itself. Yeah, okay, how to get rid of this. Okay, cool. Yeah. So the diagonal sum, what I'm doing is simply creating a list comprehension here. So for every value of the length of the matrix, I am just calculating the diagonals and returning the sum, right? It is quite simple. Um, then I create faulty rows, which is basically that you are checking whether each of the row has unique elements or not. As we discussed, the set is the right approach here. So
Mm-hmm.
I create the set and then just compare the length. So the length should be equal to what you actually have there, which actually proves that all the elements are unique. Similarly for columns also. So this is the format in Python, which is quite crisp. You can get the row of a double matrix by for row in matrix. Similarly, you can get the column by for column in zip of matrix. So that kind of helped me, and that's it. I think um, that's the case. And another good point here is I just tried to print everything in a single line, and what Python does is it sort of adds a space somewhere. And in Google Code Jam submissions, you have to have the exact output that they have shown. So if they tell you that there has to be no space between hash and the test case number, that means there cannot be a space. So even if your output has an extra space, the submission will not be done properly. So make sure your output is exactly in the same format. That's all I think. Anybody else having any other thoughts?
Mm-hmm.
I think this is the approach for this one.
Okay. All right, then we can move ahead with the second problem. Right. So the second problem was the nesting depth, which was sort of tricky one. But let's try to understand the problem. So what it asks you is, it first of all asks you for the number of test cases. So in this case, let's say n is equal to 4, right? And which means there will be 4 strings coming up next. And what you have to do is read out every number in the list. Let's say if you consider 101. So first of all, consider 1. Then your output should actually have that particular number along with the parenthesis having that same depth. So you see that the 1 is actually under one set of brace, not 2, not 3, not 0, exactly one set of parentheses. So the depth is actually equal to the value that you have here. This is a very big notion here, because once you get hint of that, once you get the hold of that understanding, the coding actually becomes very easy, right? and and also if a particular number is repeating itself, it makes more sense to cover that within the same parenthesis. So it goes like this. And yeah, I hope the problem is clear to you guys. um,
Yeah.
yeah, actually when I read
Yes.
the problem, I thought I had to implement some sort of complicated algorithm, some DFS BFS sort of a thing, but it's really necessary to understand the problem at its face. So that sort of should simplify things for you. So any solutions that you guys had that we could discuss?
Yeah. I basically used a stack.
Mm-hmm.
and I iterated over the string from the end.
Okay.
Considering the number, I first inserted the closing brackets,
Mm-hmm.
then inserted the number.
Mm-hmm.
I also had a temporary variable consider for if the next number was greater.
Okay.
So I basically inserted the closing brackets first and then the number, then the required closing brackets.
Okay.
And
Hmm.
post that I popped the elements out of the stack along with
Mm-hmm.
opening brackets, and it just
Okay.
worked out. Yeah.
All right. So if I understand correctly, you passed the string from the end. You
Yeah.
saved you saved your results in a stack and then you popped them out.
Yeah.
Okay. 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 We'll probably look at that solution as well. Anybody else having any other thoughts?
I think there were
Maybe we
people who were
can.
discussing, yeah, they were discussing this
Yeah, sure.
solution
Go
on
ahead.
the Slack.
Mm-hmm.
I think Puneet had some solution for this, right? On the Slack.
Okay. So let me open. Do you think it was somewhere on the general channel?
Yeah, Ronak, Puneet, there were folks who were discussing about the solution.
Must
Ronak,
have got
Puneet, do you want to
shared.
discuss the solution here?
Yeah, I guess
Yeah.
whatever the solution she has done, it's more or less the same. I guess so. I didn't want to like repeat the solution what she has implemented. I'll go over if you want it.
Yeah, I think we can go over it. But I think there is a difference between what my solution is, what yours is, because I'm not adding it to the stack and then popping out. I'm sort of
Uh,
just collecting the data in one string itself.
oh, what
So
what
maybe,
I did was I just kept track of the depth in a variable, and we know that every number in the string is the depth
mm-hmm,
required for the parenthesis. So first we iterate for the first element, we check what the depth is required. The initial depth is 0. So let's say the number
mm-hmm,
is 1. So we add that number of parenthesis, opening
mm-hmm,
parenthesis. Let's say depth is 1. So we add a parenthesis. Then we move on to the next element, and then we check what the current depth is required. So if the
yeah,
depth is less than what we require, so we
mm-hmm,
add more opening parentheses. If it's greater than what we need, so we
okay,
start closing there. So that's the solution, general idea. So just we need a
yeah,
current depth variable which keeps track, and then we can
mm-hmm.
append parentheses in the string along with the elements.
Yeah, right. That's the approach that I also took. So for now, we have two approaches basically. Okay, all right. Okay. Yeah, so far we have two approaches. One is to maintain the depth in a variable. Another one is maintaining a stack for the things for pushing the data and then popping it out. I think so far the second solution to me sounds better because we are not sort of adding up and then popping out. That is, I think, two-way iteration. So far we have a good solution that just do one iteration itself, and based on the depth just add on the required string that you have. So any other solution, guys, which you might have? If not, then maybe we can discuss this depth solution itself that I'm talking about, because that's what I also implemented.
Yeah. Yeah.
Okay. Yep. Okay. Right. So let's go over the approach. So I'm also doing the same approach. What I'm doing is I'm maintaining an open brackets variable, which sort of tells me how many brackets are open at any given point of time, right? Which is actually equal to the depth also, what depth I want. So for each of the character, I am finding out what is the value first of all, and based on that value, if I see that the number of open brackets are more or if the open brackets are comparatively less. So I compare the difference and I open those many brackets, right? And after those many brackets, I insert the character C, and then I update the open brackets value also. And if, let's say, at any given point of time, if I see that my open brackets are lesser, or if they are more, so depending on that, I am closing the braces, right, and then appending the character. So this sort of approach sounds comparatively better to me. And if the value is same, I'm not doing anything, not opening or not closing any braces. I'm simply appending the character, because for the same depth, you don't need to open or close any brackets. You have to just insert that character again. And at every point, of course, it is important to keep updating your open brackets variable or the depth variable. And once I'm done, I at the end of the loop, I check if there are any open brackets left. So I simply close them depending on the depth. And that's it. I print out the result.
Right.
Right. So yeah. So any thoughts or anything?
Yeah, this is actually better because using a stack, I mean, I'm using extra memory. So
Yeah.
it's of no use. Nice.
In fact, no, just using the stack would have been fine, but the iterations are double, right? Because here also I'm using at least some string, right? This result is a string, that is an extra memory, but that is only traversed once. You don't pop the strings out or anything. So I think just the iteration is the factor here, just single
No,
iteration.
actually, even my solution had only single iteration. I had a temporary variable, like you have open brackets,
Mhm.
and according to that, I pushed all of them into a stack. I could have maintained a string instead of a stack
Okay.
directly.
Yeah.
Yeah,
Yeah.
actually, it is based on a general idea of balancing the parentheses. If you have a general question of checking the balance of parentheses, you usually do it using stack, right? Push
Yeah,
the
exactly.
opening braces on the stack. But if you do it, if you just want to check the balance, you can keep that element as an integer, and then every time you see a opening base, just add one. And every time you see a closing base, subtract one. As
Hmm.
when you see zero, that's the point when you have a balanced parenthesis. You can apply the same logic here. So essentially, at
Yeah,
every point, you're just checking what is the balance of the current string and how much opening or closing bases are required at that point to maintain the balance.
Hmm.
yeah,
That's
yeah, exactly.
interesting. Yeah. Okay. All right. So if nobody else has any opinion, we can move forward to the next problem.
I don't know about others, but one challenge that I faced with this code jam
Mhm.
is in the lead code practice and all, you have everything as an input and everything is given. You just have to write
Yeah,
the function.
right.
One of the challenge I faced here was to take the input. You have to take the input also from the command line.
Yeah, exactly. I think I remember taking part in one of these competitions last year also. And it was a big challenge, especially, when the inputs are so much, it's difficult to track like which input to take when. So yeah, that I think that comes with the practice, that sort of thing. It's difficult in the first round, definitely. Okay, let's move to the third problem. Okay, right. Let me just close it out. Okay, so this is the third problem. So you can see that the very first input is number of test cases, which is 4 here. And then there is an input string, which basically represents how many activities that a couple has to do. Basically, let's call them J and C. So they have to complete these many set of activities, but the challenge is that the time limit is sort of limited, right? So what you have in the next three lines is the time frames between which these tasks have to be done. So what right, so for the same thing we'll have more inputs here depending on the test cases, and what you have to return is if there is a possibility that the couple can divide these activities between them. If it's not possible, just return impossible. But if it is possible, just return the sequence in which they should do it. So for the very first case, C can take up the first task because nothing is overlapping with the second task. You can see that the second task starts even before the first one ends. This basically means the second person will have to be taking up this activity, and the third task is after all the above two tasks. You can see it starts at 600 minutes after the midnight. So that basically means that this can be done by any of them. So yeah, so any of them can take it up. So the C takes it up, for example. So I think that's about it. The program was quite clear. I mean, the problem statement was quite clear. So yeah, any thoughts, any approaches?
Yeah, so I basically saved the tasks with their task numbers, that is their initial indices. Post
Okay.
that, post that, I sorted them according to the starting
Mm-hmm.
time. It was basically an activity selection problem, right?
Yeah, right.
So post that, when I got the result for the sorted
Mm-hmm.
array, I stored the characters with the original indices,
Okay.
original task number, and then
Yeah.
sorted this array with respect to the task number, so as to get the right answer, the sorted answer in the original order.
No, I didn't get you. The first thing you did was append the indices, then you sorted it, right?
Yeah,
Then you
yeah.
solved the
Then
problem. Let's say assigned the characters J or C.
yeah, yeah. And when actually I was using CPP, C++,
Yeah.
so
Yeah,
I
that's okay.
built two different classes,
Okay.
and in the second array was a pair where I had the character and the original index, the
Hmm.
index which was of the task, of the respective
Okay.
task. According to
Okay.
that, I sorted them. Then it went to the original,
So
order.
why do you think we need to sort twice? If you're not wrong, you're sorting twice, right?
Yeah, I'm sorting twice.
Hmm. Okay, interesting.
Because my point was when I sorted the tasks, according to the
Mm-hmm.
starting time, then
Yeah.
I've lost the actual order in which I want the answer.
No, interestingly, no, you haven't because you also saved the indices with them, right? So even if you sort them by the, let's say, the first element, you will definitely have the
Hmm.
index there, right? S-
Yeah.
So, yeah, so if you assign the, let's say you figure out the algo, you assign the characters. So now what you can do is you can probably store the characters in a list or an array at the
Hmm.
position that you the index that you have. So let's say the very first index turns out to be 1. Okay, this 364, it is an index 1 after sorting, let's say, although in this case it is 0. Let's take an example
Hmm.
where you will be able to understand. Let's take this one, the long test case that they had, fifth, sorry, when you have 5 values, right? So if you assign the indices, there will be different ones, and let's say the very
Hmm.
first 99 150 has an index 2, and you
Hmm.
assign j to it. Okay,
Right.
so when you assign it, you rather store the j in an array with
In the
index
direct
2.
position, right?
Yeah, yeah.
Yeah, I could
So
have been done.
you understand? Yeah, yeah.
Yeah,
I
yeah.
think that would be a
Definitely,
better
that
thing.
was much better solution.
Yeah. Yeah, it's just a little trick that strikes you, when you're doing it. I'm sure it would have struck you as well.
Yeah, it did, but I
So
mean, my test case is already passed, so I didn't bother
yeah,
changing it.
same here. I was so optimistic. I'll solve the next problems also. So I was like, okay, go ahead. Let's just submit the solution somehow, howsoever it works.
Yeah.
Yeah. So anybody else having thoughts? I think I saw a chat.
I do have a follow-up question on this one, not
Sure.
something that is existing, but a kind of follow-up question. Like if in this case we have like two participants only, like C and J. What if we had K participants?
Okay.
Okay.
Okay. In that case, well, I'm not sure about you guys, but I'm actually using a hash map to store which person is busy till what time. So even if you have k persons, my dictionary or rather my hash map would store those key elements and then check if any of the values or rather if any of the person is available during that time. So I'll update that.
So that will be around nk as the time complexity, right? Every time you'll have to check the entire hash map and find out which one has the space or which one is within the time limits to take up the next task, right?
Correct. Yes.
And what if we have two people who can take up the task? Which one will you decide to assign the task first?
Um, so you're asking what if two persons are available for the same activity?
Right.
Yeah, the question, I think it says that you can choose either. Both the solutions will be accepted.
Right. And let's assume that your two people right now are busy till suppose 150, time limit 150.
Mm-hmm.
Now you have two next task. One is closing at 300, another is closing at 350.
Mm-hmm.
Okay. And
Mm-hmm.
one of them starts at 150, another starts at 250.
Hmm.
Hmm. Okay.
Then what will you do? Which one will you assign? So my question essentially is if choosing one of those blocks the usage of next task.
Oh, okay.
Is it
I got
possible?
your point. I got your point. Interesting. Yeah. So, hmm.
I'm sorry, I just missed the
So I
part.
think,
What was your question?
um, so I think what he's
Let's
trying.
take this problem only, fifth point.
Yeah.
Okay. Okay, Nidhi, can you copy this one into whiteboard and share the whiteboard?
Sure. Okay. What did it do? Sorry about that.
Stop the share and then share the whiteboard.
Okay. And what do I have to do? Share a
Share
whiteboard.
screen.
Yeah.
Yeah, share screen. There will be whiteboard.
Yeah. Okay. Yeah. I did that.
Just paste the.
Okay. Trying to paste it. Says copy and then no, it's not allowing me to paste.
There will be a text icon. You can directly copy paste text.
Oh, right. Yeah. Got
Right.
it.
So let's assume we have two variables, J and C,
Hmm.
right?
Mm-hmm.
One of them is the time limit maximum, which is for J, another is for C.
Okay.
Now let's assume I gave the first task, which is 252 J. Nidhi, can you write the J and C values so that this can be.
Yeah. So let's say for this we have a J, right?
No, not here. Just keep two separate variables, J and C.
Okay. J and then C.
Yeah. So first task to be assigned to J is 2 5. Now J is busy till item 5, right? And you can mark that as used.
Okay. So used, how do I like? Should I rather do something like
Yeah,
this?
that's fine. And J will be busy till time unit 5, right? So just
Yeah.
write 5 below J. Yeah, somewhere around there. That's fine. Next item, I'll take 1 to 100 and I'll assign it to C.
C.
Yeah.
Right? So C will get busy till 100.
Okay.
Now the next item which I can take is 100. Right?
Okay. Yeah. Right.
100 to 350 or sorry, before that I have 99 to 150.
Yeah. Right. That will go to J, I think.
J. Yeah. And J will get busy till 150.
Now this 150.
Yeah. Now we have two items, 150, 301. Sorry, 100 to 301 and 150 to 250. Right? We'll take 100. Okay.
Okay. Okay.
And then we'll assign it to three. There's only one which can take C.
Yeah.
Yeah.
Right.
Right. So,
Now,
right.
in this case, because there was only one person available, we have taken it to 300. Now, suppose both of them were starting at suppose let's say one was 125. Okay, so let's suppose 100 and 301 is 125, 301,
Okay.
and 150 is 149, 150.
150 is 149. Okay. Okay.
Right. Now, if we take this item like 125, he'll get busy till 301.
Yeah.
Yeah. Right.
Right. And what will happen next is we'll not be able to take the last item at all.
Yeah. Oh, right. So basically, this will return impossible.
Yeah.
Correct. But the idea is so the thing is, if you have space available, try to accommodate the person who is maximum in that area. So suppose I have 3 people available, one can start any job, or one is busy till 100, another is 200, another is 300. And there is a job that is available at 350, try to accommodate one which is like 300. Because in future, you might have a job which is like 250 and there is someone else to accommodate that.
Right, right. I understood the point. So basically, your algo should be intelligent enough to figure out if there is a better optimal way of choosing the persons.
Correct.
I'm guessing
The
you're
problem,
hinting at dynamic programming.
Okay.
no, not dynamic problem. It's just a use of priority queue. But in the priority queue, you will have to check, like I said, if there are k elements. So the choice of your next participant will be something, instead of keeping the elements in hash, you can keep them in a tree map and just try to find the floor of that value that you need. So that will give you the person who has the highest time available, and that you will use for the assignment purpose.
Right.
Oh, yeah. Right.
So that way, you will be able to accommodate if there are k elements also, like k persons available for assignment and n jobs.
Right.
So in this case, it was easy because we had only 2. We had to compare 2 variables. So more than 3 n number of participants who can be allotted time, you can easily follow this approach.
Yes, interesting.
Right. So if we can allocate a task to multiple people, we want the optimal approach for that.
Okay. And how can we be sure that if we maintain a priority queue and whatever person is returned, that will be the most optimal one? Can we be very sure of that?
It's not just priority, it's just a sorting. But the thing is, so if you have 2 people, just assume 2 only. One is available after time 100, another is available after time 200. Right? And you have a new job coming in, which is at 210. Right? So you have 2 options, both of them can take up the job. But now if you assign it to someone who's at 100, and the next job is only at 150, Now there's no one else who can take up the job, right?
Right.
So we want to have a system where we don't want to use the time slot which can be taken up in the future also.
Oh,
Right?
okay.
If we are
Yeah, that
sorting by
makes sense.
n times only, because we can sort either by start time or end time. If you're doing it n time, you don't know the starting times of the items.
Hmm.
So start times can be in different order also, right?
Hmm.
Right.
Right, right.
So try to be greedy and assign the task to someone where the probability of new tasks coming in and still people being available is very less. That will happen if you are assigning that job to someone who has just got free or who will be free just before that item. So that in future, if there's a job coming in or in your
Yeah.
set there's a job which had to be started earlier, we can easily compute that.
Hmm. Right, right. That makes sense. That's a very good thought, actually. Yes.
Yeah.
Yes. Okay. So, so if anybody else has any thoughts, if they don't, we can probably look at the solution. Okay. So, what I'm doing is after taking all the inputs, so till here I'm just taking the inputs and building my activities array list. So once that is done, I am sorting the, also interestingly, um, as soon as I'm adding the activities, I'm also appending the index, right? So my activities sort of array list will also have an index associated, and eventually I am sorting my activities based on the starting time. So this line actually sorts my activities based on the very first index of for all the items. So once I have it all sorted,
Nidhi,
I am
hey, Nidhi, I think you're still sharing the whiteboard.
oh, oh, sorry, my bad. Okay, let me share desktop. Okay. Okay, I hope you guys can see now.
Yes.
Okay, so let me just quickly repeat. What I did was just take all the inputs. I am using an array list to save all the activities, but interestingly, I'm also appending the index towards the end so that I have a track. I don't lose the sequence when I sort it out, right? So in this line right here, I'm sorting the activities based on the very first value, which is the starting time. And as soon as I'm done sorting, I am creating a hash map for J and C to indicate till what time they are busy. So initially I'm initializing them with 0. And for each activity, what I'm doing is, if the starting time is bigger than what a particular person is busy till. So let's say if activity is 360 and the hash map for C is actually less than 360, that actually means that C can take this task up, right? So I am saving the string in a list, or rather I'm actually having a list which will save all these values. But the interesting part is I am also updating the hash map based on the activity picked up for that person, and also I am storing the result for that particular index only, right? So I guess, yeah. So this particular line actually saves the character C at the required index only. So I told you that I'm also appending the index, right? And here is what I'm making use of that. The very last index, I am taking it up. So for this activity, let's say the index was 1. So I will save the result. I will put C on the 1 index only. So my result will actually have the required data in proper order. I don't have to resort or
Right.
any other thing. So that's all. I am updating the times at after picking every activity. and if things don't match at all, the result is impossible, and that's it. I'm breaking out after that. So I'm printing out the result. That's about it.
Right.
Right. So any thoughts? Okay. So I think those were the three problems I was able to solve. Let's look at the next problem, even though I don't feel like, because this was one problem I just read and then everything was just, I don't know, I just couldn't get it. I think there was some local testing that you had to set up. So if anybody else is free to actually share for this particular problem, because I had no clue whatsoever.
Same here. Even I read the problem and could not really understand what's going on there.
I
And
can explain the problem if you want. Like,
Yeah,
I can
sure.
explain.
sure, sure.
Okay.
Yeah, sure. Sure.
So let me just share a
Yeah,
whiteboard.
you want to share? Okay.
Yeah. Can you see the whiteboard?
Yeah, we can. Please go ahead.
Okay. So let's say there is a case for 10 bits. So what they're saying is they've stored a data in an array of bits. Okay. And you can only fetch one bit at a time. Okay. From this array of bits. And what happens is after every first, 11th, 21st, and 31st, basically any query number which has a 1 at the end of it changes the array of bits into 4 operations, right? Either it could be the same, so I'll mark it as equal. Okay, it could get reversed, so whatever the original bits of array was there, the bits would get reversed in that array. Okay, it could get complemented. So what would happen is, like, for each 0 it would become 1, and for every 1 it would become 0, or it could become complemented reverse. So the bits would be
Okay.
flipped and the array would be reversed. All right. So let's just take an example. Let's say it was 1 0 1 1 0 0 1 1 3 4 5 6 7 8 9 10. So let's say this was the original array of bits that was as a data. All right. So in the first query, you'll ask for a bit number from position 1 to B. All right. So let's say I asked for the position bit 1. So what would happen is, before I get the result, because it's the first query, any of the 4 operations can happen. So a quantum change, basically what they're describing it as. So my array of bits can either remain the same, okay, or it could get reversed, or it could get complemented, or it could get complemented reversed. All right. And it would be like, first the operation is applied, the quantum operation happens, and then I get the result. So if it's say the after my first query, the whole data got complemented, so my current bits would be 0 1 0 0 1 1 0 0 1 0, and I would be returned 0. All right. Is that clear?
Why would it return only? So it returns one bit at a time?
Yeah, so the how the problem is designed is you're only allowed to fetch one bit position at a time, and it mentions in the problem is, first the quantum operation happens if the query number ends in a 1, right? And then you're returned the result. So on your first query, one of these 4 quantum operations might happen, like the array might remain the same, or it might get reversed, or it might get complemented, or it might get complemented reversed. So I assume, let's say it chooses these operations randomly, so I assume that when I asked for my first query, which is give me the first bit of the data array. Okay, so it first complemented the whole data set, and then it returned me the first bit of that data which is currently stored in their server. Okay, is that
Right.
clear?
Okay. Yeah, it's clear
Right?
now.
Okay, so I can, after this happens, I can now simply fetch for the second bit, right? Now the second bit is stored as 1, so I would be returned 1. Note these 4 operations don't happen. These happen only after I perform, like after this I can simply get the 3rd bit, the 4th bit, the 5th bit, 6th, 7th. So what the solution for the small test case was, like you first fetch the first bit, right? And then you can easily fetch the next 9 bits as well, because no quantum operation will happen after that. And you just need to return the result as what the current state of bit is in their server. So that's what they want to retrieve. So for the base case, it's pretty easy. You just make a query from 1 to 10 and you store it in an array and you return the result. Is that clear? But it gets trickier when the bit size data set gets increased. Like when you get to 20 bits, you have to return the result for 20. So when you try to fetch the 11th bit, whatever you have got up till now might get changed after these 4 operations. So then you'll need to figure out by fetching some of the bits that you have fetched earlier to see what operation actually took place, and this new bit, where does it lie.
Okay. Actually, I had a question before we get into that. I want to understand, like this part I had understood by reading the problem, but what I could not understand was how is the input and output being managed? Like,
Okay,
what is
so
the local testing tool? Yeah.
so I'll show that also. So what the local testing did was, so I'll assume that I was using C++. So I'll just say, so this is my C++, and this was the solution code they provided in Python. So this was the testing tool they provided. So what they did was, I had an std out, okay, and we have an std in, standard input and standard output. Similarly for Python, we have a standard input and a standard output. All right.
Right.
Std out. So what they did was they connected the Python's standard input to the C++ standard output. So whatever my code will output will become the input for the Python code. So let's say I outputted 1, which means I wanted to fetch the first bit. So what they will do is, like, the 1 will become the input for the Python code, and it will return me the first bit of the number. Similarly, whatever the Python code will output, it would become the input for my C++ code. So I printed out std out 1 in my C++ code. I provided it to Python. Python will input, let's say the first bit was 0. Then I will get 0 as an input for my C++ code. Okay, then I can perform operations on whatever I got the input as.
Okay, but how are you making these two interact? Like, do you have to run the Python source in the background, or?
Yeah, so you had to connect the C++ stream, input output stream, to the Python std input output. And if you didn't want to do that, basically what you could do is you could copy their Python code, all right? And then there was an option in the code editor there, like show test input code, and you could paste the Python code over there, and then you could test the submission. So it would provide a connected environment for you, so you wouldn't have to like manually do it in your local system. Another thing that I could do is, basically, if you're familiar with like Linux commands are also, so what you could have done is, like, you simply could have piped your C++ output to a text file, and you could have recursively, like for local testing, you could have recursively changed that text file. So that would have become the input for your C++ code. But the easiest way I found it was to like use their online editor and paste the Python code over there in the show test code switch, and then it would tell you whether your output was right or wrong.
Okay, so Ronak, can you like go on the CodeGem site itself and let us know how to do that? Maybe just go on the problem itself and show us like the code and the Python file where you put it, because I think this
Okay.
is something that we could really learn. It's, yeah.
So it was documented in their like interactive problem sections. I'll have to join from my laptop. Can you give me a second?
Oh, yeah, sure, sure. I'll give you.
Okay. I'll stop sharing this for now.
Okay.
Sure. Let's see.
I think in the past also they have had some interactive problems,
Yeah, yeah.
and
So
yeah.
just wait a second. Yeah, hi. And yeah, am I
Hi.
audible?
Yeah, you're audible.
Okay, just give me a second. So here, what you could do is basically you just do this,
Okay.
show test code, and in this interactive problem section, they provided the code. Let me just find it.
The .py file. Okay.
Yeah, yeah. So you download the local testing tool. You copy this. You just paste this here, and you select this language. Basically, you could have written your own testing code as well. So you could have just provided some output and waited for some input.
Okay.
Yeah, so I'll just do this Python too. So
Okay. Python 2, because this is a Python 2 file to you. Okay.
yeah, so if your test was failing, it will tell you over here only like what test failed. So the judge had some messages. So if your input had an extra new line character or contains character other than 0 or 1 or isn't, so it had like descriptive log messages for you to describe. So let's say I outputted something completely different here. So I'll put 10. If I outputted like something like this, and then I run tests, so it will tell me that
Okay.
case number 1 fails, input position out of range. So you could have tested your solution. So what I did was, I'll show you the solution as well. So how you had to solve it was, first you assume that you're going to get two ints as your input. So one was the number of test cases and the number of bits. So according to that, you had to solve. So let's say for 10 bits, you could have solved like, so what I did was, this is how, so for 1 to 10 bit, I am outputting the first I want the first bit, then I want the second bit. So when I output 1, I receive an input D, so which is the ith bit of the array that is stored in their side. So what you had to do is continuous. You had to like output a query, then wait for an input, then you could use it as a result. Okay, is that, does that make sense for anyone to
Yeah.
go ahead and how to implement this in their language of their choice? So
Yeah. So you're simply printing out the the bit position, and the test code is actually giving you
The input.
the input. Yeah, okay.
So they have mentioned a pseudo code over here. So what they did was like this reads 100 into T and into B. This is, I guess, Python, I guess. So one thing you have to do, make sure is like every time you print something to the standard output, you have to flush the output. So in C++, we do that using endl. It might differ for your language. Okay, whatever you choose, like for Java, it might be different. Clear the stream
Okay.
output buffer. So one thing for this interactive problem was this only. So you had to flush out the standard output every time you made something for a query. Let's say I want the first bit, then I had to flush the standard output. Similarly, when I outputted the result, I had to flush the standard output after that. And finally, after you output your solution of the bits, it will give you a character whether it was right or wrong. So if it was wrong, you had to stop taking input. Otherwise, you will get a TLE. So that's the basic structure of how you were supposed to solve this interactive problem. I didn't have a solution for like 20th bit or let's say 100 bit. I was not able to solve, but I was at least able to get through how to run this problem. So I hope it helps someone and they can actually implement it.
Yeah, I mean this was really helpful because most of us were really confused with the interactive thing. That setup was really tricky. But thank you so much for providing
Yes.
your perspective here.
Yeah, sure. Okay.
Yeah,
I
thanks a
as
lot, Ronak.
Okay.
so if
So you
you
want to
don't
share for the next solution as well? Go ahead if you want to.
okay. So I solved this for the small test case only. I was not able to solve it for the large one. It gave me a TLE. So what the problem is it's similar to the first problem. You're given a matrix. Okay. So what they're saying is you have to generate this. Earlier it was like you were given a matrix and you had to find how many rows were repeated and how many columns are repeated, right? We were given the constraints that in each row the numbers would be from 1 to n, non-repeated, and in each column as well. Okay. And we had to calculate the trace. Okay. In the first problem, which was the easier one. In this, what we have to do is we're given n. So in 3 by 3 matrix, and we are given the trace, like what should be the trace of the matrix. Okay. And we have to generate this Latin matrix, natural Latin square, where the trace is like 6 and each row and column has distinct elements from 1 to n without repeating. Okay, so if anybody wants to share their thought process on this, how they would go about doing this, or I'll tell my solution after that, how was I able to solve for the small test case, but maybe you could discuss what you're thinking or what you'll approach this problem with. I'll explain the first test case as well. Okay, so it says like we need a 3 by 3 matrix with the trace sum as 6. So what the output is generated is it is possible, and the trace elements are like 2, the diagonal elements are 2, 2 and 2, and you can see this row has 1, 2, 3 distinct elements, 3 to 1 and 1, 3 through. Similarly, the columns have no repeating characters. So this is a valid answer for having the trace as 6 and n by n is 3. The second case is impossible because they have shown us that sample case 2 has no answer, because the only two possible 2 by 2 natural Latin squares are 1 2 2 1 and 2 1 1 2, because if you put like 2 here, then in this column 2 will be repeating. Similarly, if you put 2 here and 1 here and then 1 here, so 1 and 1 would be repeating. So has anybody thought about it, or should I go ahead? Just let me know.
I
You can share what.
actually, yeah, I actually did with the backtracking. I could only complete the first part. Every time I added a node, I just checked whether it was possible, first of all, whether to create that trace on the diagonal with that element adding. For example, if I was adding 5, 5, and 5, that is 15, and that was, the trace required was only 12, so I would not go forward that path in the backtracking algorithm. Same case if I was adding some value and the remaining, that's the remaining value that needs to be added. That is also not possible. I would stop the backtracking over there. So it was more of a backtracking algorithm, but wherever you could prune the cases, I could just stop there. That's the approach I did first. Then the second approach which I tried, because there was just not working for the 50 nodes, was first trying to create the diagonal and then trying to create the backtracking for filling up that, but still for the 50 elements it's not working. It did improve the performance for the smaller test case, but for the ones which is having like 50 nodes was not able to really run that much.
Right. Yeah. So that's the approach I also did. I had something different from your approaches. I didn't. The way I chose my options of the next option what to choose is basically how you solve a Sudoku. Like if you guys have ever solved a Sudoku, is like you try to eliminate like what are the possible choices of this cell. Okay, you see what the possible choices of this cell are, and you try to solve it. Let's say if a cell has only one possible choice, you fill it because you know that's the only possible choice. And if it was a wrong choice, you'll eventually figure out that this results in repeating numbers in rows or columns. So what I did was, uh, what I did was, let me check. Yeah. So first of all, yeah. So first you check whether you have filled, or the base case is whether you have filled the complete matrix or not, right? So this is just a simple complete function where you check whether everything is set or not in that row. And the trace sum, like the diagonal sum, is equal to the sum that we want. So if this is true, then you have found a solution. If not, so I find the element which has the minimum number of choices. So what I do is I iterate over all the elements that I have not set yet, and I count how many possible choices are there. So what this is, these are basically 2 bit sets, and I'm count for every bit it's like 1 to n. So let's say my n is 5, so I would have 5 bits, 1 1 2 3 4 5, and this has 0 4. So what I did is I'm counting the minimum number of bits. So the row set bit is counting what elements I have in my row. So this is from 1 to n. The first bit represents whether I have set 1 in the row. The second represents whether I have set 2 in the row. Similarly, 3, 4, and 5. Basically, instead of creating a set or a frequency map, I am doing it with the bit set. So each bit represents the ith number in the row. It has been set or not. Similarly, for this, I have not set 1 in this column till now. I have set 2 in the column, 3 in the column, but not 4. So this has 2 choices. Okay, kind of like this. How I'm finding the cell with the minimum choices. So I'm storing it in min I and min j. Then I'm checking whether it's a valid choice. Basically iterating over all the choices in that cell and further getting deeper in the matrix. So that's how I'm backtracking after that. So I'm recursively calling solve after I set it to this option where I check whether this is a valid option or not. Then I set it to that matrix position, and then I'm updating the bit sets, and I'm recursively calling solve for this.
Right.
Okay.
Same approach, but different way of creating that set.
Yeah. So basically, what I found after that, what I was doing is basically, if you want to read up, is Donald Nutt's X algorithm. So this is what it is basically. So basically, the final test case is for this only. What I implemented is a depth first backtracking algorithm, and you find where there is the least number of choices available. You pick that and you do depth first. But this
Yeah,
is
it will have the, if there's wrong, it will terminate early.
yeah, but it is like I didn't understand. And there were like, if you want, I can paste this in the chat. So if anybody wants to do a further reading for this,
Just put it on the Slack. Okay, I'll do
yeah,
it.
I'll post it on the Slack as well.
Yeah, just put it on the thread only.
Yeah,
Click on
I'll
the
put,
thread.
basically after that, what I saw in solutions of other people was they first calculated in a depth first way whether the trace was possible or not. So they did that first, and then they solved it using a bipartite coloring algorithm. I was not able to understand that. I haven't researched it yet, but yeah. So what they did was bipartite.
Yeah, they did it using bipartition matching, and before that, just created a diagonal using a DFS.
Yeah, but this only works for like for n equal to 5, less than equal to 5. This times out on 50 test cases.
Which one?
My solution, what I did,
Yeah,
it gives me a TLE on n equal to 50. So yeah,
that's great. Yeah,
Okay.
that's good.
Actually, I also tried to solve this problem, but somehow it kept giving me that the answer is wrong. But can I just discuss my approach? Maybe I
Sure,
can
sure.
try
Go
to
ahead.
share the
yeah,
screen.
sure. I'll stop sharing. Yeah.
Yeah. Okay. Okay. I hope you guys can see.
Yeah.
Okay. Cool. So let me show you what I'm doing. It's not one of the best things that I could do, but that's the only thing that came to my mind. So let's say my input is 3 space 6. So that basically means that
Yeah,
a
just
3
a
cross
minute.
3.
Just a minute. Sorry. I just could see one mistake that I also did. I just wanted to. So if you see the combinations that you have created, like
Mm-hmm.
3, 2, 1, 2, 3, 1, 2, 1,
Yeah.
3, and everything. If you see, you don't need all three of them. Only one of them will actually represent your matrix. Now you'll ask why? Because these are diagonal matrices, diagonal elements, right?
Yeah.
What you're creating is diagonal elements. So whether the one lies in the top, second, or third position, all the other elements will arrange themselves accordingly. So if you have three diagonal elements, 1, 2, 3, and you can create a matrix out of that, you can also create a matrix out of 3, 2. If these are the three diagonal elements, you are just
Um,
going to place your rows up and down, right?
right.
So if you
So,
are considering these columns as your diagonal elements, which can give
mhm.
you sum of 6, you just need 1, 2, 3. And the second combination, of course, will be 2, 2, 2.
Okay.
Are you considering that, or is it just a combination of all 50 elements, or just random
Hmm.
combinations?
Okay. Okay. Yeah, maybe I can try to implement that. But for now, what I did was I just created all the combinations, as you can see, right? So the comps variable basically has all the permutations of the 1, 2, 3, right? Now the next thing I'm doing is I sort of returned a two-dimensional array, right? Max, which basically has all the valid cases that can be arranged between these. I know, I mean, this looks quite tedious, but for a minute, just bear with me. So as you can see, I have one combination like this. So this also sounds valid, right? It has unique elements, and let's not consider the diagonal sum for now. So I am returning all the possible valid matrices. And
Right.
once I have all that, I am checking for each of the value if the diagonal sum is what I want, right? So if there is a possibility, I'm simply returning it possible and then breaking out. So I want to understand what is wrong that my solution was not accepted. Um, just
Can
that.
you show what is your output when you print it out?
Yeah, sure. Let me. Okay, quick.
I think there's a space at the end.
Okay, what space?
For I equal to j in range, you are adding a space after every element, right? So your actual output is 3, 2, 1 space.
Yeah, but I am also stripping out the output after each line.
Oh, I don't know Python that much.
Okay,
Three, two,
how can I
one.
check that? Yeah, no way to check. Okay, that's one thing. Okay, I'll look into that. But any other thing that you think might be wrong?
You are creating the permutations of all, and then you're getting all the matrices. Can you try some other combination instead of 3 and 6 one? Just try any other.
Okay. So let me try 2, 3, 1. Yeah, this was fine.
Just
Let's try a valid case, right?
yeah,
So let's try for 4 or
12.
there is a problem, looks like. List index out of range. Okay, that's then maybe I'll dig deep into that. Maybe I've messed up something here.
Yeah,
Okay,
maybe
no
the
problem.
index is wrong.
Yeah, must be something. Okay, then cool. I think we are done discussing all the problems.
Yeah.
So, okay, if anybody else has any questions or inputs.
Okay. I think yes, we can end the.
We can wrap up.
You can
Yeah, it
stop the
was a long
recording
session.
and.
Okay. Okay.
Thank you, everyone.